Alright guys, so I just posted the video of me solving the basic stoichiometry mole-to-mole problems, as well as one of the problems that is just one step longer, from either moles to grams or grams to moles. Okay, so now I wanted to do a separate video for gram to gram stoich because it's just a little bit longer. It's one extra step. So I'm going to solve number 8, and then I will not solve 9 and 10, but the key is on its learning. Okay, so this is the same process as you've been using for several weeks now, where you start with your given over 1 and keep opening up steps. You're solving it with what we call dimensional analysis, right? This setup is called dimensional analysis. It's always your given over 1, and you just keep dropping units until you get to the unit that you want to be in. Okay? So you always make sure you have a balanced chemical reaction. This one's already done for you. And you want to make sure you're clear on what you're given, and it's important that you know your units and your substance. And you want to know what you're going to. What do you want to solve for? What do you want to be your last unit that you don't cancel out in this dimensional analysis? Okay, so if you like to kind of think ahead and plan what your problem's going to look like, you can see that you're going from grams to grams. So you're going all the way from the very beginning of the mole map to moles a given, to moles a wanted, all the way to grams of your wanted. Okay. Before this section, you were just doing moles to moles, or mass to moles, or moles to mass. Okay, so this one you're going from the very beginning to the very end. So they're going to be little 4-stepper problems. So same old, 204 grams of aluminum oxide is my given. Set it over 1 and immediately open up another conversion. Okay, drop your units. Drop the gram and drop the aluminum oxide. Alright, and then if you don't know what to do from here, look at the dang mole map. Okay, you are here. You are at grams a given. You just dropped that unit. You don't know what goes on top. The only option is the next circle, moles a given. So moles of aluminum oxide. Aluminum oxide is my given. Aluminum is my wanted. Okay, I'm sorry, this is kind of zooming in and out. Okay, so my mass for aluminum oxide, I already calculated it up in the previous video. I had 2 aluminums, 3 oxygens, got those masses from the periodic table, and added them up to get 101.96. Okay, now, moles of aluminum oxide. This is where I am. Okay, I just did this step. This is not my mole ratio step, right? It does not look like moles a wanted over moles a given. So you do not use the coefficient for aluminum oxide here. This is still just 1 mole, just like normal. So you've canceled out grams, you're in moles of aluminum oxide, and you open up another conversion because you're not where you want to be. Drop your units. Moles of aluminum oxide. You may not know what to do from here, so check your mole map. I just put moles a given on the bottom. Moles a wanted can go on top. This is the step. This is the step that you can use your mole ratio. I wanted moles of aluminum, so moles of aluminum oxide is 4. Moles of aluminum is 8. Okay. And then I cancel out my units, and I decide if I'm stopping here. I'm in moles of aluminum, and I said I wanted grams of aluminum. No problem. Just keep going. Drop your units. Moles of aluminum. I am no longer in my 1 step that I use the coefficients. So 1 goes with the mole, and I want the grams of aluminum on top. That number from the periodic table, G, I better look at my periodic table, is 26.982. I'm just going to use 26.98. Okay, and then to solve that, you are multiplying everything on the top and dividing anything on the bottom. Do the top first. 204 times 8 times 26.98, divide by 101.96, divide by 4. And you get 107.94 grams of aluminum. 107.94 grams of aluminum. Okay, take it 2 places in. So on these, the rest of these, numbers 9 and 10, I will have the key worked out for you on its learning. Don't forget to balance first, and don't forget to use your mole map.